Hi dear students. So the next question is based on formal charge. Based on formal charge. So what is the formal charge formula? First, if you calculate the formal charge, for which you calculate formal charge, for that atom how many valence electrons are present? So number of valence electrons minus number of lone pair of electrons for that atom minus half into how many bond pair of electrons are present surrounded by that atom. So that is the formal charge. So ozone molecule, we know that ozone means O3. O. So the structure of the O3 molecule, Lewis dot structure is so double bond O. So that means next 2 here 1 2 3 4 5 6 1 2 3 4. So 1 2. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. Each oxygen has a number of valence electrons 6, total 18 electrons. So 18 electrons in ozone molecule. So what is the charge? So if it is first oxygen atom, if it is the second oxygen atom, it is the first oxygen atom, if it is second oxygen atom. So calculate the formal charge of first oxygen atom for this oxygen atom. So first number of valence electrons, whatever the oxygen atom, number of valence electrons are 6 because 6th A group, minus number of lone pair of electrons. How many lone pairs are present? 1 2 3 4. So number of lone pair of electrons, not lone pairs. So 1 2 3 4, 4 electrons minus half into number of bond pair of electrons, half into number of bond pairs, 2 bond pairs. That means 1 2 3 4. So 4. So that equal to 6 minus 4 minus 4 by 2. 6 minus 6, 0. So for first oxygen atom, formal charge is 0. Formal charge of second oxygen atom. So why for second oxygen only he find out the formal charges on terminal oxygens. So it is a terminal, it is terminal. For 2 terminal oxygen atoms we calculate the formal charges. So formal charge of second oxygen atom is equal to number of valence electrons 6 minus number of lone pair of electrons 1 2 3 4 5 6 minus half into number of bond pair of electrons 2. 6 minus 6, 0. 0 minus 2 by 2 minus 1. So answer 0 and minus 1. So answer D. So how to write these lone pairs here? Based on Lewis dot structure. So based on Lewis dot structure, we calculate the formal charge. So next, the formal charges of atoms 1, 2 and 3 in the ion. It is 1, it is 2, it is 3. 1, 2, 3 ions. 1, 2, 3 atoms in the ion. So what is the formal charge again? Formal charge of first oxygen atom. Oxygen atom. So number of lone pair of electrons, how many? So here 2 lone pairs, here no lone pairs. So here 2 lone pairs. First oxygen atom, 6 valence electrons minus number of lone pair of electrons, so 4 minus half into number of bond pairs, 1 2 3 4. So 4. So 6 minus 6, 0. 4 minus 4 by 2 means 2, 0. Formal charge of nitrogen. How many valence electrons on nitrogen? Nitrogen 5th A group element. So valence electrons 5. Minus how many lone pairs? There is no lone pair of electrons, 0. Minus half into number of bond pairs 4. That means 4 into 2. Each bond contains 2 electrons. 4 bond pairs, 1 2 3 4. So 8. 5 minus 8 by 2, 4. So oxidation state plus 1. So next formal charge of this oxygen. Same. 6 valence electrons minus number of lone pair of electrons 4. Half into number of bond pair of electrons 4. So 6 minus 4 minus 2, 0. So that means 0 plus 1, 0. So answer is 0 plus 1, 0. So option B. So not this. Okay, next question. The set of molecules in which the central atom is not obeying the octet rule. So which one not obey the octet rule? So for example, If you take CO2, C double bond O, double bond O. The central atom, how many electrons are present? 1, 2, 3, 4, 5, 6, 7, 8. So if central atom has 8 electrons, so it obeys octet rule. So in which the central atom is not obeying the octet rule. So it obeys the octet rule. So no need to check the remaining answers. Remaining one. So B, if you check H2O, H2O, oxygen, 2 hydrogens. So oxygen has 2 lone pairs. So 1, 2, 3, 4, 5, 6, 7, 8. So it is also central atom obeys the octet rule. So it is also not correct answer. So if you check the C, CH4, CH4. So 1, 2, 3, 4, 5, 6, 7, 8. So it is also obeys the octet rule. If central atom has octet, it obeys the octet rule. So it is also correct. So if you check option D, yes, F6, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So central atom has 12 electrons. So it is expanded octet. Expanded octet. So like PCl5. P 1, 2, 3, 4, 5. 5 chlorines. 5 into 2. 5 into 2. How many electrons? 10 electrons. So it is also central atom has expanded octet. XeF2. XeF of valence electrons in central atom Xe8. Already 2 electrons are present. 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 electrons. So it is also expanded octet. So answer D. So if you check the central atom, how many electrons surrounded by that atom, that is the if octet or less than octet or more than octet. But the question is the set of molecules in which the central atom is not obeying the octet rule means answer D. 24th question. Dipole moment order of which of the following pairs of molecules is not correct? So very easy. Dipole moment. We know that dipole moment means dipole moment formula mu is equal to E into D. Dipole moment mu is equal to E into D. E means magnitude of the charge and D means the distance between the two charges in a molecule. So first one, HF, HCl. When compared to HF and HCl, HF more electronegative. So fluorine is more electronegative. So electrons are shifted towards fluorine atom is more. So mu HF is more than the mu HCl. So dipole moment order which of the following pairs is correct? So A is correct. So here also dipole moment towards HCl, but fluorine has more electronegativity. That's why HF dipole moment is greater than the HCl dipole moment. Next one B, H2S, yes, H. So one lone pair. So next CO2, C double bond O, double bond O. So here the dipole moment towards oxygen atom, here dipole moment towards oxygen atom. So net dipole moment 0. So here also mu H2S. Here dipole moment towards more electronegative sulfur atom. Here also more electronegative sulfur atom. So due to the lone pair, the dipole moment towards the sulfur atom, net dipole moment is totally upward direction. So mu H2S is greater than mu CO2. Next, if you check option C, NH3, so one lone pair is present, NF3. So both are pyramidal in shape, but here when compared to hydrogen, nitrogen more electronegative towards nitrogen atom dipole moment. So due to the lone pair of electrons, dipole moment is upward direction, total dipole moment is upward direction, but here when compared to nitrogen, fluorine more electronegative. So dipole moment for 3 fluorine atoms downward direction, 1 lone pair upward direction. These two are cancelled by each other. So dipole moment downward direction, and when compared to this one decreases. So mu NH3 is greater than mu NF3. So finally D, CH4. CH4 means there is no lone pair of electrons, tetrahedral shape, mu is equal to 0 for CH4. For BeCl2 without lone pair of electrons, PCl5, SF6, next IF7. For that molecules dipole moment is 0. So next one CHCl3, CHCl. So due to this chlorine atom net dipole moment 0, but hydrogen atom, chlorine atom, so dipole moment is in this direction. So when compared to CH4, CHCl3 dipole moment is more. So mu CHCl3 is greater than mu CH4. But here CH4 is greater than CHCl3. So which one is incorrect means option D. So remaining all are correct. H2S, CO2. So second option correct. First option correct. Third option also correct. So answer D. A very important dipole moment. So okay, note this one. See the next question. Choose the correct option from the following. If you know the Fajon's rules, then only you answered these questions. These two questions answered by when you only know the Fajon's rules. So first Fajon's rules. Already you learned in IP. For a given cation. Given cation means cation constant. Sodium. For a given cation, size of anion increases, covalent character or covalent nature increases. Size of anion, fluorine, chlorine, bromine, iodine. Top to bottom size increases. Size of anion increases, covalent character also increases. So because we know that ionic bond, which cation and which anion forms ionic bond? Largest cation, smallest anion forms strong ionic bond. Small cation, large anion forms covalent bond. Like that, cation constant. If anion size increases, covalent nature increases. Very important one. Next, for a given anion constant, fluorine. Size of cation decreases, covalent nature increases. So size of cation decreases, covalent nature increases. So size of cation, lithium has a small size, so more covalent character because anion constant. So next, high charged cation and high charged anion forms covalent bond. If NaCl is there, Na plus Cl minus, plus 1 minus 1, low charges. If MgCl2 is there, Mg plus 2 Cl minus, one cation is higher charge, anion lower charge. If MgO is there, Mg plus 2 O minus 2, both are higher charges. That means higher charges means the formation of covalent bonding nature increases, lower charges means ionic bonding nature increases. So here MgO, Mg plus 2 O minus 2. So higher charges means covalent bond formation increases. It is covalent nature. So Na2O, Na plus 1, oxygen minus 2. So when compared to this one, charges are less. NaCl, Na plus 1, Cl minus 1, plus 1 minus 1. So charges very less. So it is ionic in nature, it is covalent in nature. So next one, cation with pseudo inert gas configuration, covalent inert gas configuration is ionic. In a molecule, for example Ag plus has pseudo inert gas configuration. What is the meaning of pseudo inert gas configuration? Pseudo inert gas means 18 electrons are present in their valence shell. If 8 electrons are present, that is inert gas configuration. If 18 electrons are present, that is pseudo inert gas configuration. So Ag plus has pseudo inert gas configuration, Na plus has inert gas configuration. So that's why NaCl is ionic, AgCl is covalent in nature. Based on this, so first one, Kf is more covalent than Ki. For a given cation constant. For a given cation, size of anion increases, covalent nature increases. Size of anion increases, covalent nature increases. So it is more covalent, it is less covalent. So first one wrong. because Kf is ionic, Ka is covalent. SnCl4 is less covalent than SnCl2. Here Sn charge is plus 4, tin charge plus 4, here Sn charge plus 2. Large sized cation forms ionic bond, small sized cation forms covalent bond. Sn plus 4 means number of electrons, 4 electrons lost. 4 electrons lost means size decreases. If here only 2 electrons lost, 2 electrons lost means small size. 4 electrons lost means very small size. Very small size means Sn plus 4 is more covalent. So it is also wrong. He is given less covalent. So understand? Sn plus 4, Sn plus 2. Here only 2 electrons lost, here 4 electrons lost. The size of Sn plus 4 is very less. Small sized cations forms covalent bonds, but here less covalent. So wrong. LiF is more covalent than Kf for given anion constant. For a given anion, size of cation decreases, covalent nature increases. Size of cation decreases, so small cation, large anion. Covalent nature increases, so more covalent. LiF is more covalent. Anion constant, but small sized cation, large sized cation. Small sized cation forms covalent bond, large sized cation forms ionic bond. So it is correct. Last one, ZnCl2 is less covalent than NaCl. ZnCl2 is less covalent than NaCl. Na plus Cl minus, Zn plus 2 Cl minus. Zn plus 2 has pseudo inert gas configuration, Na plus has inert gas configuration. So it is more covalent. So it is also given wrong. So next question, the combination of which of the following compound gives an ionic compound with maximum covalent character? So high charged cation and high charged anion forms covalent bond. So which one has high charge and cation and high charge anion? Mg plus 2, O minus 2. So answer B. So remaining plus 2 minus 1, plus 1 minus 1, plus 1 minus 2. So higher charge cation and higher charge anion forms covalent bond. So in these, which one has a strong ionic bond? Na plus, Br minus. Low charge cation, low charge anion forms a strong ionic bond. Okay, note this.